Okay everyone, I wanted just to take a quick minute to go ahead and give you a hint in regards to the homework that's due tomorrow, Thursday, November 20th for HVAC MECE 414. I have here a slide for the homework assignment. You have here a pump. This pump is pushing water in the direction I'm indicating here. So water is flowing and then it splits here into this piping network and then gets split here. The water then flows through, as I'm indicating here by drawing, and then it merges back here to 4 and then continues to go back towards the pump. Some more water comes here and splits down to 3, comes back, merges back at 5. What I really wanted to do with this was just to take a minute and to explain how to handle the losses associated with branches and throughs, because that's something that we covered in class the day before, Friday last week, but I'm not sure if everyone at the moment understood what I was getting at. So here is a hint. There are going to be several sections of the pipes. They're all indicated here. You have section 5.1P2, 5.1 pump 2, that's one section. Section 2.4, which goes this way. Section 2.3, which is between here and here. Section 3.4, which is this way. 3.5, and then 4.5. Those are all the different sections of pipe. And what the homework what this problem is asking you to do is size the pipes and find which path has the greatest resistance. Now, there's also two other parts of the problem, part B and C. I am eliminating from you needing to do. I had originally had that in here, and I will actually go ahead and after this video erase part B and part C because we didn't take time to cover that in class, so I'm not too worried about you understanding that. But what I really want you to do is to find which path has the greatest total head loss. Now, what I want to take a second to do right now is to go ahead and to go over one more time the strategy for handling losses associated with branches and throughs. So let's look at this split here at point 2. We have water flowing, right, that splits down into this section and that section, which incurs a through and a branch loss. So this section here is flowing this way is section 2.4. So what I would do is that I would count this as a branch loss on section 2.4. So when you have in your Excel spreadsheet, you have for section 2.4 all the losses associated with that section. You would have 2 elbows, 1, 2 elbows, and then you would have a branch as well. And the loss would be calculated according to the diameter of section 2.4. And then for section 2.3, you would only have one loss associated with section 2.3, which would be the through. And you would calculate the loss associated with the through according to the diameter of section 2.3. Now, I hope that's clear. If it isn't, you can email me. I'd like to do a second quick example looking at how to count it when it merges. What I mean by merges is, if you look at here at section 3, I have water flowing through section 3.5 and it merges back at point 5 right here. And then water flows that way. So I have water flowing down, merging in, and water flowing over and merging as well. So again, you would count the loss against the section to which it's merging to. What I mean is, if I look at section 5.1P2, which is this section right here, all of the fitting losses would be 2 elbows, right? There's 2 elbows present here. There would be 1 through and then 1 branch. So there would be 3 different types of losses associated with this section of pipe, 5.1 pump 2. There would be 2 elbows, 1 through, and 1 branch. And I would evaluate the loss according to the diameter of section 5.1P2. So again, one more time. Water's flowing. Let's look back up at the first example. Water's flowing through, splits down through section 2.4, and then also goes through section 2.3. So section 2.4 would have losses for 2 elbows and 1 branch, all evaluated at the section 2.4 diameter. Section 2.3 would have 1 through loss associated with, calculated according to the diameter of section 2.3. Section 5.1P2 would have loss associated with 2 elbows evaluated at the diameter of section 5.1P2. You would have 1 branch, since the water is flowing this way, merging back here, and then water is also flowing through this way. I would have also a loss for 1 branch in section 5.1P2 evaluated at the diameter of section 5.1P2, and 1 through to section 5.1P2 evaluated at this section's diameter. So that would have a total of 3 different losses: 2 elbows, 1 through, and 1 branch. I hope that's clear. I will post the homework solutions tomorrow, probably in the morning, and you also have similar examples with the solutions to exam number 3. Please, if you have any questions, let me know. I know that it might be frustrating that there's an exam on Friday and I'm not present this week to field questions, but I am very responsive by email, and if it even comes down to needing to make a phone call, I can do that as well. So please make sure you email me if you have any questions. I hope this video helps.